This video is about the language of risk. We'll begin with a definition. There are many definitions out there, and I'm a pragmatist, so I'm not going to say which are right and which are wrong, but some are a little bit better and some are a little bit worse. This happens to be one that works well for me. So let's read this. Risk is a measure of the probability and consequence of uncertain future events. I like to tease three elements out of this definition. First, there has to be an undesirable outcome. A risk has to have some sort of harm. Something has to happen that we don't want to happen. So that undesirable outcome is often a loss, but it could also be a gain that we fail to realize. The second part of this definition that's important is this undesirable outcome may or may not happen. There has to be some chance or likelihood so that we're not really sure how this will turn out. And element 3, of course, just reinforces this very notion by saying there has to be some uncertainty here. And since risks are always looking forward to things that haven't yet occurred, there's always going to be some uncertainty. And so I find these are the three key elements of a risk, at least the three that we'll be considering in this class. Before leaving this idea of different definitions of risk, however, I should offer you at least one alternative. And the International Organization for Standardization, ISO, defines risk this way. It's the effect of uncertainty on objectives. So different people are going to prefer different definitions. Don't be surprised if after taking this course you step into some sort of arena where they define risk in an entirely different way. What I think is consistent and constant in all of these risk definitions, however, is there is going to be an undesirable outcome that may or may not happen. I'd like now to distinguish two categories of risk. There are some people who like to distinguish risk and reward and treat them as different things. I'm not one of those people. And I find more and more people are willing to describe two different kinds of risk, and I've identified them here. Pure risk is the risk of loss. When we are talking about pure risk, the risk manager's job is loss prevention. Some examples of risk of loss, or these pure risks, would be natural disasters, financial setbacks, adverse health effects, and those sorts of things that most people would agree, yes, indeed, they are risks. The second kind of risk, which some people sometimes distinguish as reward and a separate topic, would be speculative risks. These are opportunities for gain. When faced with these sorts of risks, the risk manager's job is to prudently take risks to create value. So some examples of speculative risk would include things like your new job doesn't bring you the happiness that you hoped for. Your $1 investment in the Mega Million lottery doesn't hit. Ecosystem restoration investments fail to produce the benefits that were desired. And so we'll be distinguishing two different categories of risk as we move through this course. One will be the risk that you will lose something of value to you. The other is that you might take steps that will not result in the gains that you hoped for. Conceptualizing risk is another messy area. If you just take a second or two and do a web search for risk equations, you will find any number of the formulations in front of you here, and possibly some that aren't here. I like the one at the top. That's the one we'll be using in this course, and so let me begin with that. It says risk is a consequence times a probability. Now, it's very important that you understand this is not a literal equation. By that, I mean it will be relatively rare that you will be able to estimate a risk by simply multiplying two numbers together. So if this is not a literal equation, what is it? And I like to look at it as a conceptual model that basically says the risk, which we just defined a minute ago, has these two very important concepts. There has to be a consequence and there has to be a probability. and they are presented in a multiplicative fashion to make this point. If the consequence is zero, there's no harm, then it doesn't matter how likely that event is to occur. There's going to be no risk because there is no harm and no consequence. On the other hand, no matter how large the consequence of an event is, if its probability of occurrence is zero, then there's going to be no risk. And so I leave to you, looking at this equation and thinking about informally and developing your own intuition about how a consequence might be big and a probability small, or vice versa, and that these would create a wide range of potential risks in that conceptual way of big risks, small risks, and so on. But again, it is not a literal equation for estimating risks. The second bullet says risk is a hazard times an exposure. There are some communities of practice, the food safety community, for example, that uses hazard instead of a consequence. So the hazard might be a pathogenic microbe. And instead of probability, they use the word exposure. So the risk would be the likelihood of you becoming exposed to this particular hazard. The third bullet is yet another permutation of this basic idea. There's an impact times a probability. There are a great many people who would say, if you were only looking at consequence and probability or impact and probability, you're missing important dimensions of a risk. And I don't disagree with that at all. It's just a question of how much of that do you want to put into this conceptual model. So bullet 4 shows risk is a function of a threat, the vulnerability of your asset, and the harm that could occur to the asset. So they break out a third dimension of vulnerability here. The next bullet says risk is a function of the hazard, the exposure, the vulnerability, the consequence, and the uncertainty. So you can see that there are other people out there who want to tease out more elements of the risk than just the consequence and the probability. The last two bullets there I leave to you. These are indeed formulations that are available in the literature, but I would not be the person who would be best equipped to explain them to you. I find them a little difficult to penetrate. Risk equals hazard times vulnerability over capacity. This is a version of risk that's used in the healthcare systems. The last bullet, I've not really seen a precise definition of how you would interpret risk here. But here's the point. The language of risk is really messy, and the way people conceptualize this can vary from one field of practice or one community of practice to another. The big difference, as I see it, is if you take that consequence in the very first bullet, some people want to break that consequence down. They want to know what the vulnerability is, what the threat is, what's the asset. And I'm agreeing that at some point you're going to have to address all those things. I don't find it necessary to address it when we're conceptualizing risk. And so in this course, we're going to define risk initially using this top equation. And we're going to say risk is a consequence times a probability. Each element has to be present or there is no risk. Here's a brief taxonomy of risk. To illustrate what I mean here, I'm going to use a relatively simple example, one that I hope most every listener could identify with. So let's imagine that you live alongside a river and that the river floods from time to time. Well, then you know that you have an existing risk. The river might come up once every 10 years and flood you, on average. It might be an annual sort of event. Whatever the circumstances are, there would be some sort of existing risk. That risk might be changing. In the future, that risk might be greater. That risk might be greater because upstream of you, the land is being developed. There is more impermeable surface, more rain runoff, and your flood problem may be expected to get worse. That would be a future risk. Future risk and existing risk are sometimes different. Historical risk would be looking backward. So perhaps in the past the flood risk wasn't as great for a similar reason, that there wasn't as much development in the watershed and there was less runoff. At bullet 4, we're looking at risk reductions. If the government were to come into your community and build a levee, they would be reducing some of your flood risk. And so the amount by which they reduce that risk would be called a risk reduction. Sometimes when we manage risks, we create new risks. For example, if the government comes in and builds a levee, you now have a new risk. There could be a collapse of the levee. That's not a risk that existed in your community before. Residual risk. This is an important idea that's often overlooked. When we identified the very first bullet, we said there's an existing risk. There's an existing flood risk. The government comes in with a risk reduction strategy, build a levee, so they reduce some risk. But they didn't reduce all of the risk. There could still be a flood large enough to overtop that levee and flood the community. And so that risk that remains after you implement risk management options is called a residual risk. A transferred risk is a risk that can be pushed off onto other people, other geographic spaces, other points in time. And in our example here, if there is a levee that's built in your community, that keeps water from moving onto your community, but that water has to go somewhere, and it might be pushed to the community on the other side of the river, or it might be transferred into a community downstream of you, and so you would be transferring some risk. A transformed risk is when an existing risk changes in its basic nature. So before the levee, perhaps the river would come up rather slowly and evenly, rising throughout the floodplain and throughout your community. But now that you have this levee in place, you have a risk that's transformed. Those low levels of flooding are protected and confined are confined by the levee. But once the water gets above the levee, then you're going to have a very different kind of risk. You're going to have sudden catastrophic overtopping. So bear in mind that when people talk about risk, they may be talking about one or more of these different elements of a risk and not carefully distinguishing it. So make sure that you learn and use the language properly. We're going to just take one point away from this initial discussion, and that is this. The language of risk isn't settled, and it can be confusing to people who are trying to learn it. Even the most basic terms do not have commonly recognized and agreed to definitions. The International Organization for Standardization worked hard to try to do that, and they did so for their membership. But their membership doesn't include all the government agencies of the various national governments around the world that don't subscribe to the ISO definitions. And so don't be concerned if you find as you get into this risk field that when you read in one article terms are defined one way, and then when you go to the next article or book they're defined in another way. The language of risk is not settled.